Hello, my name is Erick Malaret from Applied Coherent Technology. Very happy to be here to show you some of the new developments in Lunar QUICKMAP related to mission planning capabilities. Very upfront, I'm showing you some of the high-level capabilities and results in QUICKMAP, in case I run out of time. On the left-hand side, you see a 3D simulation starship showing tracks of the sun, the moon over a particular period of time. And also you can see on the bottom here, like tracking cameras that wherever you are, they are pointing at entities that are very relevant to you, like the sun, the earth, the lander, and also nadir pointing cameras. On the right-hand side, what you actually see is a traverse being executed by an astronaut. Let's see, is it playing? For some reason, there. So basically, you can control the speed, how fast you speed this up in time. But normally, it's a walking speed of an astronaut going through the traverse. Far away, you can see the actual starship is starting to lose contact to the starship if it continues on that path. And there's a lot of metadata information that is shown on the top. The rest of the presentation will elaborate on this, but at least you already have an intuition of what are the capabilities that are coming in this new mission planning tool. For those of you that are not familiar with QUICKMAP, this is a product that it has been in existence for over 10 years. We have been collaborating with Arizona State University and NASA, the LRO project. QUICKMAP has a lot of similarities to other data viewers, but has a lot of uniqueness that are very specific. The philosophy is that we want to have geophysical parameters in numeric data accessible. So you can put a dot and extract a profile. You can put a blob region and extract a data cube. You can inspect over any of the spatial profiles over the data. And it gives you a lot of capabilities for accessing the data, visualizing, doing sensor fusion. You know, the list is long, but the purpose of this presentation is not to go over what is QUICKMAP. But I need to highlight, last year we added a class that we call Terrain. And Terrain always provides you the best DEM that is publicly released and available. So no matter where you go on the moon, you will have the best resolution of data that has been publicly released. And that's very powerful because it gets updated automatically with every time ASU does, they do a update to PDS. Then there's another tool that is called QUICKMAP Terrain Shadows that allows to do synthetic lunar image modeling. So you can simulate shadows, even in the pole where some of the shadows can come from 100 kilometers away. And as a function of time, and this can be very precise computations, or it can be very interactive also. We were blessed to have over 700 unique users, depending on the metric is higher, per day. And I know that it's over 2 petabytes now of lunar data that is in the system. That number is all 1.5 petabytes. So with QUICKMAP, you can do rapid environmental assessment of lighting conditions with the new capabilities, and that's very important. I will try to move quickly away from what it was, but show you some of the new enhancements that we have been adding. There are enhancements that have been done to QUICKMAP, also that involves adding new data layers, adding capabilities to generate mosaics, basically NACS matching illumination conditions at some future time. And also, let me do this here. Okay, yeah, here you see on the right-hand side, you see an actual showing a solar eclipse actually happening, simulated in QTS 3D. What I like to concentrate a little bit of time is there are many new layers that we added this year. What I'm showing you is already available in the public QUICKMAP. There are a lot of new diviner data. There's a lot of There's a new group that is LROG-NAC A3 sites. That is basically, as new data is published for over the candidate landing sites for Artemis 3, it starts showing up in that group. There's something very relevant that happened in this version of QUICKMAP that is now in 3D, when you go to the poles, it renders very nicely. It's polar optimized, and you can see data that is, you don't see a lot of gores going into the poles. It looks quite nice. Also, you can navigate with a gamepad controller. You can connect it to QUICKMAP, and it's like you're flying a drone over the surface of the planet in the poles. You also can load your own temporal geotiff cubes. On the right-hand side, we are basically illustrating this layer non-matching illumination at some particular time. This is a very powerful new layer that was added. It's constructing a mosaic on the fly, that is how the lighting conditions are going to be at that point in time in the future or in the past, using NAC images that match those illumination conditions. It's generated on the fly, and it's quite powerful. Let's see, next slide. Here is a comparison of the NAC machines illumination to actual simulated data coming from the QTS2D, where it's purely simulated, and you can see they match quite well. Why that's relevant? Because when you don't have NAC images, now you can simulate the data. So you can try to use the best you have in observations, or you can switch to simulated data. There's a new capability in QTS2D. We created a console mode. QTS2D allows to generate high quality, highly precise illumination conditions, including shadows coming from far away, and including surface temperature, sunlit regions. But we have expanded the QTS2D now to deal with when you have a large number of time intervals, maybe the whole calendar year or more, that you like to compute data. And we're calling these conditions and evaluation cubes. Short, we call them ice cubes. And they are really temporal geotiff files. But this is extremely powerful. When you are interested in going a candidate landing site or so, you can generate these ice cubes, and you can then interact with them as they provide you highly precise information of a illumination condition. One byproduct that it has there is hours of light ahead, which means that you put a pixel at a given time, and it tells you exactly how many hours of light you will have, for how much time you will have data. 2 minutes. This is a product where you see yellow basically is the actual hours of light ahead, that you at least have 6 days of light. That's an example. Let me switch here to QTS3D. Now in QTS3D, we can simulate the different conditions. We can generate traverses. We can generate a traverse, design a traverse, and visualize the traverse. Let me give you more insight into this. When you evaluate a traverse, you can also see here, this bar tells you when you have visibility to the sun along the traverse and to Earth, or to the lander. This is very relevant because here you see you lost visibility to the lander in this region of the traverse. Or you can go to a particular point and say, at this point, show me over time what is going to be my visibility. And these bars here give you the exact times that you're going to lose visibility to sun, Earth, or lander also. There are many capabilities in the new version of QUICKMAP Terrain Shadows 3D. This is basically over Tycho doing flying a drone, but you can also have another model you can attach to the ground, and basically you are navigating the actual rover over the ground. This is great for if you're planning a rover or landing, you can use this to plan a mission. There are excellent views of this Tycho crater. I'm not going to let it go all the way. We also added a capability that gives you panoramic views. No matter the lat long and height, you can say, give me a 360 view, and it gives you that amazing view that you see here, and you see the tracks of the sun and also of Earth as a function over that period of time, at that time, over the time of interest. Concluding remarks. Well, we have new capabilities that allows users to develop a comprehensive intuition and understanding of the lunar environment via interactive sensor fusion, first-person view, flyovers, and ground perspectives. We have updated the QUICKMAP system. QTS 3D new capabilities are under password control. The IceCube data products can be generated on the request, and these are highly precise cartographic data cubes. We plan to continue adding Artemis relevant data. We refined the traverse simulator, incorporate a hub-key photometric model, support astronaut training with QUICKMAP and QTS 3D. And we are exploring creating a standalone version of QUICKMAP that can be for a particular region that doesn't require to have the internet connected to it. QUICKMAP, basically, you can run it on any device, including from your iPhones to any web browser. Presently, there's a Lunar QUICKMAP that has been in existence for a long time. Mercury QUICKMAP that is being used also by Bepi Colombo. We are collaborating with Johns Hopkins Applied Physics Lab, and it has all the messenger data. Mars QUICKMAP, it has all the new data releases from CRISM, and they are all functional. We're getting close to release a version of Enceladus QUICKMAP, and we welcome your feedback and how to keep improving it for lunar applications. If you haven't used it, please use it. You will find it very simple to use. Okay. Thank you, Eric. Thank you.